not having gaps, like the, I don't know, if you give them like the generic car, you know, that is really clean, not too many surfaces, that you can get grid on it pretty easily. I feel like the form of the car, for example, is not quite as user-friendly. In fact, there's a lot more connectors and there's a lot more surfaces that turn into connectors when you do that, so there's a lot more detail fine-tuning to do. So in terms of this, that helps a lot if your trailing edge is nice and rounded like that. You know,
So zoom back in again with that same shot. I think that's really the crucial thing. Did you make a connector with a certain resolution along this part?
Yeah. So what I did, I think what I first did for this one, after I gridded, I just extruded all three of the elements about as far as I thought that they should go in terms of just capturing the boundary layer. And then to do the grid in between, I went ahead and split now the lower surface of the airfoil, what would be the upper surface. So this surface, I just split the domain.
You can split the domain rather than the connector,
Yeah.
it's true.
Yeah. So I split this here, so I split that domain there, and that gave me the ability to increase the resolution right there. And, so what I ended up doing is I tried to match the resolution.
You see how the size of the triangles are similar to the size of the quadrilaterals? That's perfect. There's no jump in spacing here. There's no funky, highly skewed-looking triangles or quadrilaterals here. This is as good as you're going to get. Going from this type of grid to this grid back.
Right, so I think what I did is, off of this extrusion, I took the biggest cell and looked at the spacing here, which is 0.01. And then I believe that's what I shot for this spacing to be, so that there is a smooth transition.
This is in 0.01 inches.
I think so. Yeah, inches.
You got a lot of grid. You got a lot of grid far away here. Probably unnecessary.
Yeah,
right?
that was something. You don't need that much grid on the inflow up here, especially in this corner. Maybe I would need it down here because I'm in ground effect. It might be useful, but up here I don't think there's any needs for that. As well as a little bit up here too.
Which brings up a point. If you really want to control the amount of grid locally near your airport, you could put a box, literally a box, using 4 connectors around this section, and let it triangulate at a high level in that box, and then from that box to the wind tunnel walls, you have become much more porous. So you can do it that way. You have kind of stages from box to box to box if you want more fine control over resolution. We might just try to get really fine resolution in this near wing, and because of that, you had to pay the price. He's carrying a lot of grid everywhere.
So here, if you look at this one, again, I split this domain from there to there, so I can keep the spacing in there and just add double or triple the number of points if I need to, so that the average size matches what I have down here. You can also, I think if you select these 2 connectors, grid, dimension, you can set the dimension with an average, redimension it through grid and dimension with an average delta S, which then if you measure what this average delta S is, 0.03, then you can kind of get an idea of where this should be. That makes sense.
Instead of using a number of points, you use a spacing, right? An average spacing. This gap here, Mike, is what? It's bigger than 1%, right? Or
I kind of just eyeballed it, so it's
why not?
2.4.
this is probably the easiest way to go, is to do the extrusion, I think, to do the extrusion of both the airfoils and then triangulate the in between. It's a little easier than the T-Rex.
Yeah.
Are there any questions about this approach? Maybe a snapshot of this, posting it or something would be useful. I don't know. Should we get a snapshot of this so people can remember what it looks like? Can you do that, Mike? Can you make a print screen?
Yeah.
We'll get a little closer in first to show the detail. There you go.
So in that stage thing, like control box or whatever box, you would still want, you still would not want like a big jump that.
No, you still don't want a big jump in section. But the way you avoid that is in the little box, you put a decay factor of point, you had like what, 0.99 or something? 0.95 or 0.99. The decay factor, the number you put at the very bottom, the attributes. Something decay factor.
Yeah.
I think I've ever seen that.
Anyway, that is what defines, that's what controls how fast the spacing changes in the triangles, the resolution. So you can put 0.99 for the little box around the airfoil, and then 0.5 for the bigger box that reaches the wind tunnel, and that way it'll go from flying to course in a hurry, where you don't care anyway.
Yeah.
And you won't have any spacing jump either.
So here, if you go to grid and then solve, after you've already selected the unstructured domain, you can change what it is here. So 0.99, if we make it, the default is 0.5.
Yeah, so that's what the difference is that.
And then if we apply, I think I have to initialize. See, that's what it is.
So the grid comes to course in a hurry, which he didn't want to do because he wanted to retain some grid resolution in the vicinity of the action.
Right. So if we zoom back into here, it's okay, but it's, so we look at the differences.
It looks much nicer.
So there's the boundary decay of 0.5, and then there's 0.99. That's one of the only ways you can really control the unstructured grid.
So that's the key number. Decay factor.
So that's the extruded grid.
Are there any other questions about the extruded grid? Before we move on? I know a lot of you are doing the extruded. That's what I've seen.
And the T-Rex grid. So I've got it with a, I realized that my domain was too small, so I increased it. But similar thing, I think I have a decay factor on the unstructured domain of, again, 0.99.
Your inflow boundary is a little close.
Yeah. And then here's what the T-Rex grid looks like. So,
Highly skewed triangles.
and then I think the other grid looks a little bit cleaner in this transition.
Still looks a lot better than what I had in class on Friday.
And so this one I didn't even go into splitting this up to do it. So I think it could even look a little bit better if I split this. If I split this, I think it would look even better.
Yeah. It's not a fair comparison. Let me see your settings on your let me see here. Show what his settings were. He has a maximum number of layers of 20 advancements before it goes to a triangulated grid. So you have a maximum number of 20 layers. And 7 requirement, you have at least 7 full layers. That is extrudes along all surfaces without any kind of, not any kind of hiccup. 7 complete extruded layers and up to 20. Where's your run? We don't know whether you're working in inches or are you working in inches or meters? Your grid.
This is inches.
Okay, so your spacings. Bring your spacing. That's what I wanted to show. The point I wanted to make is he's got different walls with different spacings. You don't have to have them all advanced in the T-Rex. Unlike the extruded thing, you can have things advanced at different rates, and it will just, you know, what do you call it? It'll it'll take care of the differences automatically for you. But the .0005, that's for which wall? Is that for one of the smaller elements?
That's one I
Leading edge?
can't find it.
Oh, because you're looking for it.
Yeah.
I think I thought it was like that, she highlighted blue.
Oh, it's this one. The one trailing edge they have.
Right. That looks pretty good in that area. So you could conceivably have a little more control by putting different spacings for the extrusions on different walls.
Each airfoil I have set as a different boundary condition, so I could change the spacing there. For I guess this trailing edge, I had to make it a smaller spacing because the airfoil itself is a little bit smaller, and so to get the right aspect ratio on the cells looking okay. The ventilator will be thicker there, so you don't need quite as much.
On your attributes, do you have smoothing turned on, or? Oh, got you don't have it turned on, okay.
I guess it's set as default, maybe.
Yeah. Okay.
Yeah.
You didn't mess with that.
What you were saying, this is 3D, but what you were saying about making a box around it is what I did for here. You can see that, so there's my wing inside of there, and then I have this box inside which has a much finer grid, and then I have a much coarser grid out here. So it's a little bit different because it's 3D, but it's the same idea, just a box around it with a finer grid. More number of points for each connector. You know, so
This is a T-Rex grid.
Right, so this connector has 128 versus this one has 25. So even though it's half the distance or a third of the distance, it's got way more points. This one actually just extruded, I think.
You extruded that portion?
Yeah, I extruded the surface of the wing to have boundary conditions of the endpoint and the wall.
It was only for that one time.
And I coated in with
Oh, okay, so it's not T-Rex, right?
So that's in 3D what you were talking about with the draw a box around this, and then you can have like 3 times, 4 times as many points in that small box as you can in the big box.
It's not all that much harder than doing the other extruded grid. I think it's pretty similar. A little work involved. I think what we ought to do now is Mike and I go around and look at what you got in terms of your 2 grids. Mostly interested in your double element grid. And if you don't have that, then we'll look at the single element grid to see where you guys are, and we can suggest anything to correct it. So if you don't mind, put it up on your screen. We've got one per team. I know we don't have licenses, so Pointwise on everyone. Everybody ready?